Hi, and welcome back to Allen High School's APIB HL1 chemistry class. What we're focusing on in this video is an introduction, a brief introduction to the separation of mixtures and some of the techniques that are used. We're going to zero in on two common ones. There's many things, but we just want to get you started along the pathway of thinking in terms of this. The first is chromatography, a very common tool that is used in science. You may have even heard it if you watch like the CSI kind of programs. And this can be used for both identification or separation of mixtures. Now, chromatography, the word originally comes from color because color played a part in how these molecules were visualized, but it's not, it's not really like our spectroscopy that we do. All right, in this case, what we're doing is we're separating often based on difference in solubility. Okay. Now, there's a variety of types of chromatography. There's gas chromatography, so it can be solubility in a carrier gas, or it can be solubility or attraction to intermolecular forces, attraction to a solid phase. All right, so which you now know, right? Solubility is dictated by intermolecular forces. Now, there are some that separate their size exclusion techniques, or they can be charge exchange techniques. If you look at the column in the back of the classroom where I make my deionized water, that's an ion exchange column. So as the water goes through that column, it's going to be pulling out the ions from the water so that the water would be pure. Okay, now the substance that is being separated, what we are interested in, what we are analyzing, is called the analyte, and the eluent is the solvent that moves and carries it through a stationary phase. So there's three parts. There's a stationary phase, and then there's a solvent that drags the analyte through the stationary phase. And these can be liquid or gas phases, or liquid adhering to solid phases. There's really, a whole slew of techniques, all right? But one of the general commonalities that they have is that each technique has a stationary phase, and they have a mobile phase. The stationary phase is typically a solid or a liquid that is supported on a solid based on its attraction or adhesion, right? We've learned these words now. Adhesion to some sort of a solid. You can think of it as solid substrate. Or sometimes they'll use like a silica gel. There is paper chromatography. There is something called thin layer chromatography that's very similar. Or there can be columns, much like what you see when I deionize with the deionized water. Okay. Now, if the analyte is more soluble in the mobile phase, it's going to move quickly. Those things that are less soluble in the mobile phase will move slowly. And so what you do is you collect them as they come off the end of the column, or it moves closer to the top of a thin layer, and you can visualize it because they'll separate it because they will move fast or slow depending on their solubility and their intermolecular force attractions to that solvent. Analytes that are more soluble in the stationary phase or adhere more to the stationary phase tend to move more slowly. So based on that movement, we can separate. Okay, the retention time This is a little bit more for column chromatography. We measure something slightly different here, but you could certainly measure a time if you needed to. But the retention time is the time it takes for the analyte to pass through the column. Now, we have to have a way to detect the analyte, and so one way of many could be to use spectroscopy. Remember, we used that, just our Spec 20s that we've used in class already. I've heard, rumor has it, that you loved the Penny Lab performing it with the spectrophotometer, but apparently a few of you did not like writing up that lab. It was pretty intense, wasn't it? Okay, so this is time on this axis. So as they came off of the column, we would visualize the peaks right here, and we'd be collecting them in different vials, okay? And that would, then we could measure the retention time. And you can measure it by mass spectroscopy, which we will eventually be covering, maybe not this year, but certainly for next year we will. Mass spectrometry separates, or detects, not separates, detects based on a mass to charge ratio. It forms ions and then separates those ions based on their mass to charge ratio. Conductivity, so if it's ionic, it will conduct, and we can measure that conductivity. Ionization detectors form ions, and so it goes through a process where it's bombarded with electrons, forms ions, and then we can detect those ions. So there's a variety of ways to do it. And that's really what I'm after at that stage, is for you to realize that there's a variety of ways we can detect the analyte as it comes off of the column. Okay. Now this shows paper chromatography, and so this would be like a piece of filter paper. We would have a solvent down here, and what you would do is you would start your samples at the bottom. And there was a really good YouTube on this one that I really encourage you to watch. It showed some fluorescent dyes, and I thought it was pretty cool. So what happens is, as the solvent moves up the paper, it brings the different parts of the mixture with it. And depending on their relative attraction to the solvent, they move at different rates and are split or separated. So what started as 1 point here got divided into 3 points. Now, thin layer is a similar process, but instead of using paper, it's going to use some sort of plate with a silica gel on it, a little bit more expensive, a little bit more accurate. So you have a solvent or mobile phase. The plate is your stationary phase. You put your sample here, and as it moves up, so this might show kind of a time-lapsed example here, that as the solvent moves up, it gets separated. And you can identify mixtures that way, and there are sometimes ways, this is a little harder to do a separation. It's more of an identification, because, you know, how are you going to get that off of the plate? It can be done, but, you know, that makes it a little bit more problematic. So. All right, and the last one is much simpler than the chromatography. Distillation separates based on differences in boiling points. And substances with the weakest intermolecular forces, i.e., those are the ones with the lowest boiling points, right? If they have a weak intermolecular force, it doesn't take much energy to break that intermolecular force, so they boil at a lower temperature. We would call those the most volatile ones. Will be separated first. The other thing you can do is you can separate a salt from water. If you just put it in an evaporating dish, you're going to evaporate off the water, but you lose the water. It's gone. So you haven't truly separated. All you've done is pulled out the salt. If you use this type of a distillation apparatus, you can recapture the water and the salt. So what's done is you have your mixture here, you heat it somehow. You'll see pictures with a Bunsen burner, but this is often done with flammable substances. So I chose to show one with a heating mantle. And so you will heat it, and the most volatile ones will start to vaporize. And you have a thermometer here so you can measure that boiling point. Now what this is this is a condenser. It has cold water that's going to quickly decrease the temperature, cause the intermolecular forces to reform, right? So intermolecular forces will reform. In other words, it will condense into the liquid and you capture that liquid. It's called a distillate. Okay, the more volatile component. And, if you could, set this up properly, you in theory could change out these flasks in between and recapture a variety of substances. If it's just a mixture of two, you get one to come here, so you've got one substance in this flask and the second substance is left behind. Okay, now there's more complicated types of distillation. There's something called fractional distillation, but this is the underlying technique in separating, taking crude oil and separating it into all of the different oil-based products that we have. We use the massive distillation columns, okay, that can do that separation. Wow, that was a lot, but we are done for now, and I think it's with less than your typical 45 minutes of videos from me in a night. So I will see you in class, and we will work on ways to help you learn this. This gave you a framework. Now we want ways to help you really firm up that learning in preparation for assessments. So see you later. Good night.